Hey friends, my name is Z and you're watching CIE Makes It Easy. And welcome to a new video for IGCSE at Maths, and today we have rules and examples for Factor and Remainder Theorem. And we'll look into questions for Factor and Remainder Theorem next lesson, but anyways, here's the rules and examples starting with some basics. And before you get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And anyways, here are some basics. Number one, we have some key terms. We have number one, coefficient, and it's basically the number before a variable. For example, in 7x squared, the coefficient of x squared is 7, because x squared is a variable and 7 is a constant or a number. Number two, a constant is a number or a letter, like C, but it is not x and y. They are not, because x and y, they are variable. Number three, a degree of a polynomial is basically the highest power. So for example, in a cubic equation like y equals x cubed, the degree of this function is a degree of 3, because 3 is the highest power. So even if you have like this plus x squared, the degree is still 3. Number four, equation. And basically an equation uses an equal sign. So this is, let's say, this is an equation, this is an equation, but if it's just like this, without any equal sign, it'll be an expression, not an equation. And number five, identity. And identity always uses this symbol right here, which means it's always true. Like, let's say, x will always be x and stuff, and we'll look more into it later in the next few slides. And we'll look into some polynomial identities. So as we see just now, the symbol for it's always true, basically a squared minus b squared is always true, it's always equal to a plus b and a minus b. It's always true, it's an identity. So this will be useful when you're trying to find for A or B or C in some circumstances. For example, in this example question, we have x squared minus 2x, x cubed minus 2x squared plus 5 is always equal to ax and x minus 1 squared plus b, x minus 1 plus c. So it's quite complicated as you see first, but you can get used to it. So what you do is that you have to try to find like step by step of all the unknowns like A, B, and C. So in this case, it will be much easier to find C for the first unknown or the constant. So you can notice that all of these, like A and B, they're attached to a function like x minus 1 squared or x minus 1. And anything, remember that anything times by 0 will be 0, like nothing. So you notice that if x were to be 1, then 1 minus 1 will be 0, then A and B will be gone. So what you can do first is that for finding C, you can set everything, you can set x by 1. So it will be 1 cubed minus 2 1 squared plus 5, which is what I wrote here. And on the right hand side, it will be a times 1 times by 1 minus 1 squared right here, and b times 1 minus 1 right here, plus c, because c has no x value to it. So if you expand the bracket, it will be 1 minus 2 plus 5 on the left hand side, and it's always equal to, or in this case you can just write an equal sign to c, which means that c is 4, right here. You can see how they relate. And number two, for finding either A or B, and I proceeded to find B. So once you have what c is, you can just substitute c by 4, right here. So what I did here was that I factorized x minus 1 out of everything. But before that, I minus both sides by 4. So the first equation, I minus both sides by 4 to get x cubed minus 2x squared plus 1. Then next step, I factorize x minus 1 like here. And then I divide both sides by x minus 1, like use long division, which we'll look into it later, to get this, x squared minus x minus x minus 1, to get this. So now what I did next was that from just now, the method from just now, I substituted x by 1 in all case, to get 1 squared minus 1 equals ax and times by 1 minus 1 plus b. Therefore b gets us minus 1. And lastly, when we have what a and b is, we can just find it from here because basically it's a shortcut right here. And you can find what a is right here. So the main thing to know in polynomial identity is that you have to spot how to cancel out the unknowns to only be left with one unknown. Because in most cases, or in all cases, there will be multiple unknowns, and you have to see how to cancel out a few unknowns so that only one unknown is left. Then we have dividing polynomials, and here we have some basics for dividing polynomials and dividing fraction actually for this one. So we have a standard division, basically 3 divided by 7 can be written as 3 over 7, which is right here. So this is basically what it's like, the whole thing. So we have a divide sign, and basically the number on the top is called a quotient, and this will be a divisor, and dividend, and remainder. So like dividend, divisor, quotient, and remainder. Like so. So here's more on dividing polynomial, and this is what we call long division of polynomials. So as when you have like a function, and let's set the function as x squared plus 11x plus 10, and let's say you have to do like x squared plus 11x plus 10, divide by x plus 1, this divide by this. Basically it's written as this, as we see just now. The one in the inside, like after the divide sign, is on the outside. It's a divisor, like so. So basically how you divide a polynomial is that you put the divisor and all of it into the divide sign. And first you just start with 1. Let's just do it so that we rewrite it. So we have x squared plus 11x plus 10 divided by x plus 1. Oops. And this long division is the same as normal division. So just find, basically what you have to do is that you have to match this x value by the first value of what comes up. So what I mean is that from here, from x to x squared, you have to times by x. So you just put an x. So x times x is x squared, and x times 1 is 1. Sorry, is x. So plus x. And to get rid of the x squared and x squared, you just minus both sides. So x squared minus x squared is 0, but 11x minus x is plus 10x. Then you pull this down to get plus 10. So from the same as just now, you have to get from x to 10x because 10x is the first number. So it'll be 10 because 10 plus x will be 10x. So it'll be plus 10x. And 10 times 1 will be 10. And minus everything will be 0. So when you know that when you have a factor of like a remainder of 0, then this is a factor. That means that x squared plus 11x plus 10 is equal to x plus 1, x plus 10. Right here, let's see. X plus 10, and x plus 1, and x plus 1. And then we have more for dividing polynomials. So here's what's 7x to the power 4 minus 10x cubed plus 3x squared plus 3x minus 3 divided by x minus 1. And it's the same as just now. So first we have, let's zoom in. We have the whole equation, the long expression right here, divided by x minus 1. So what I did first was that I tried to find the value with times by x to have 7x to the power 4. In this case, it's quite straightforward. It's 7x to the power 3. Because 7x to the power 3 times by x will be 7x to the power 4. So this 7x to the power 3 times by x will be 7x to the power 4. And 7x to the power 3 times minus 1 will be minus 7x cubed, which is right here. So it will be minus, you minus everything. 7x to the power 4 minus 7x to the power 4 will be 0. And minus 10x cubed minus 7x cubed will be minus 10x cubed plus 7x cubed, which is minus 3x cubed, which is right here. And after that, we have to just drag this value down below here to get minus 3x cubed plus 3x squared. So to find the next value which times by x to get minus 3x cubed. In this case, it's basically minus 3x squared. So we'll put minus 3x squared up on here, times by x to get minus 3x cubed. And don't forget the second value right here. So minus 3x squared times by minus 1, we get plus 3x squared. Which is right here, plus 3x squared. Minus both sides to get 0 and 0. And they all cancel out. So let's just drag this down here. Just drag both of these down here. And here to get 3x minus 3. So for the last value, just find off something times by x to get 3x. In this case, it's 3. So it'll be 3 times x to get 3x right here. And 3 times minus 1 is minus 3. So divide everything, minus everything to get 0. That means that the remainder is 0. That means that this is a fact, x minus 1 is a factor. So therefore it means that 7x to the power of 4 minus 10x cubed plus 3x squared plus 3x minus 3 equals 7x cubed minus 3x squared plus 3 times by x minus 1. And you can probably further simplify this for math. Then we have which is basically what I said just now. So this is the quotient, the dividend, and the divisor. Then we have remainder theorem, some basics for remainder theorem. So the remainder theorem is a formula that is used to find the remainder when a polynomial is divided by a linear polynomial. So it's quite complicated, so I'll show you some examples. And basically, remainder theorem is to find the remainder of when a function is divided by another function. So if the polynomial f of x is divided by x minus a, then the remainder is f of a, where this is basically put a into it. So to basically know what to put into the f of x, you just look at what it has to be divided by. In this case, it's x minus a. So we'll set this x minus a equals 0 and find x. So x in this case will be a. And that's what you put into f of x. So here's an example. What is the remainder when x cubed plus 2x is divided by x plus 3? So basically the function is x cubed plus 2x. So what it is when it's divided by x plus 3? So set x plus 3 equals 0 and find x, which is basically x equals minus 3. So that's what you're going to put into the f of x. So it will be f of x when x equals minus 3 equals minus 3 cubed plus 2 minus 3. And if you pop this into a calculator, it will be minus 3 cubed plus 2 minus 3. You get minus 33. That means that the remainder when x cubed plus 2x is divided by x plus 3 is minus 33. That means that when it's not 0, that means that this is not a factor. Then here's factor theorem, some basics. And the factor theorem is a theorem linking factors and zeros of a polynomial. So if x minus a is a factor of f of x, then f of a is equal to 0. And this is basically the remainder. The remainder will be equal to 0. So remainder and factor theorem are quite similar and they are used interchangeably. So basically the difference is that for remainder theorem, you're trying to find what the remainder is. But for factor theorem, you know that if you're trying to find the factor, you know that the factor will be when the function, when the remainder is equal to 0. In this case, it's 0. So to know what I mean is that, let's say you have this example right here. F of x equals 3x cubed minus 5x squared minus 16x plus 12. Given that x plus 2 is a factor of f of x, let's just focus on this point right here first. So it's given us that x plus 2 is a factor of f of x. That means that to find what to put into the f of x, it will be x plus 2 equals 0 and x equals minus 2. That means that you have to substitute the x by minus 2 in the f of x to find the factor. To find the remainder. To show you all. So it'll be f of minus 2 equals 3 minus 2 cubed minus 5 minus 2 squared minus 16 minus 2 plus 12. And if you pop this into your calculator, you'll get minus 12, which is basically 0. So we know that the whole function divided by x plus 2 will be 0. That means that x plus 2 is a factor because there's no remainder. So move to a few slides before. We know that when I divide everything, the whole function by x minus 1, it will equal to 0. The remainder is 0. That means that x minus 1 is a factor. So that's how it's a factor. So for part B of this example, I'll just talk through it without doing it because I'll do it later. So it says factorize f of x completely. So what you do is that you just do the long division of dividing 3x cubed minus 5x squared minus 16x plus 12 divided by x plus 2 to get like a degree of 2 of like a whole polynomial, and you can just simplify from there. Or you can't simplify if there's no real number, just leave it there. Then here's finding remainder of factor as I said just now. So let's say you have f of x equals x squared minus 3x plus 2. What is the remainder when it is divided by x minus 2? So as I said, let x minus 2 equals 0, and therefore x equals 2, so you have to factorize, so we have to substitute x equals 2 into the f of x, right here. So it will be f of 2 equals 2 squared, right here, minus 3 times 2, right here, plus 2, so it's 0. So if it's 0, in this case it is, then there's no remainder. That means that x minus 2 is a factor. Is a factor. No remainder. And here's another example. We have f of x equals x to the power 6 plus 2x times x minus 1 minus 4. And find the remainder when it's divided by x minus 1. Right here. Oops. X minus 1. So let x minus 1 equals 0 and therefore x equals 1. Therefore substitute the x by 1. So it will be f of 1 equals 1 to the power 6 plus 2 times 1 times 1 minus 4. And it will give us minus 3. It is not 0. It is not. Right? And it is not 0 because the remainder is not 0. That means that x minus 1 is not a factor of f of x. It's not. If it's not 0, so let's just say it is a remainder. If remainder is 0, that means that it's a factor. Oops. That means that it's a factor of the whole function. If the remainder is not 0, then it's not a factor. Right here. And lastly, we have some examples for factor and remainder theorem. So given f of x equals 2x cubed plus ax squared plus bx minus 9, find a and b if f of x has a factor of x minus 3 but a remainder of 8 when divided by x plus 1. So it's basically combining factor theorem and remainder theorem together. So let's just focus on number 1. F of x has a factor of x minus 3. So to see what to put into the f of x, the x value, it will be x minus 3 equals 0 and x equals 3. So for number 1, f of 3 equals 2 to the power 2 times 3 to the power of 3 plus a 3 squared plus b times 3 minus 9 equals 0. It's equal to 0. Oops. It's equal to 0 because it's a factor. As you can see here, a factor. If you expand the bracket out, it will be 45 plus 9a plus 3b equals 0. And if you simplify, it will be 9a plus 3b equals minus 45. And therefore, 3a plus b equals minus 15. That's number 1. Let's split right here. 3a plus b equals minus 15. Number 1. Right here. Let's highlight this. And number 2. It has a remainder of 8 when divided by x plus 1. So to see what to put into the x, it will be x plus 1 equals 0, which means x is minus 1. So it will be f of minus 1 equals 2 minus 1 cubed plus a minus 1 squared plus b minus 1 minus 9 equals 8. So it's equal to 8 and it's not 0. That means that the remainder is 8 and they're not 0. That means that x plus 1 is not a factor. So if you simplify, it'll be 2 times minus 1 cubed minus 9, which is minus 11 plus a minus b equals 8, and it'll be a minus b equals 8 plus 11, which is 19. Right here. Oops. Right here. So now you have two equations. You have 1 and 2. You can do simultaneous equation. Let me just drop this out. Right here. Let's give it a moment. Alright, so number 1. It's 3a plus b equals minus 15. Number 2. A minus b equals 19. So what you can do is that you can just cancel b because it's much easier to cancel. So what you do is just add both sides together because b plus minus b is 0. So 3 plus a is 4a plus 0 equals minus 15 plus 19 is basically 19 minus 15 or 4. So it's basically 4a equals to 4 and a equals to 1. So now you have what a is. You can just basically put it into the second equation to get 1 minus b equals 19, and just minus both sides by 19 and plus both sides by b to get what b is. Therefore, a is 1 and b is minus 18, and these are the final values. And that's it for this video for rules and examples for factor and remainder theorem. And I hope you'll find it useful and helpful, and if you did, please leave a like and subscribe and ring the notification bell so that you don't miss out on any future videos. And if you have any comments or constructive feedback about my channel or my YouTube or my website, just drop that in the comment section and I'll reply to them. And if you have any confusion, just drop that in the comment section as well or drop me an email. And also check out my Instagram in the description for more daily content as well as other social medias like LinkedIn. And if you need any teaching resources or any learning resources, just check it out in my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be questions for factor and remainder theorem. But until then, stay safe and happy learning.